This is questions 29, 31 and 38 in exercise 5.2 in Project Maths 2. We should write each of the following in the form a root b, where a and b are natural numbers. So we'll look at question 29 first. We've got 5 root 2 plus 4 root 2. So because we've got the same number underneath the square root sign in each of these, we can just add them together the same way we would as if they were an x or a y or any other variable. So it's just going to be 5 plus 4, which is 9. So the answer is just going to be 9 root 2, like that. And the same sort of rule applies when you're doing a subtraction. So for the next one we have 7 root 5 minus 4 root 5. So the number under the square roots is the same. So 7 minus 4 is 3, so we just get 3 root 5. And this only gets a little bit difficult when we get to questions like 38, where we don't have the same number under the square roots, but we can try to simplify each of them down. So if we try to simplify down 20, 20 could be written as the square root of 4 times 5. And the reason that I chose 4 and 5 and not 2 and 10 is that 4 is a perfect square, so we'll be able to simplify that out. And then root 45 can be rewritten as the square root of 9 times 5. And again, 9 is chosen because it is a perfect square. And root 80 can be rewritten as the square root of 16 times 5. And again, the reason 16 is chosen is because it is a perfect square. Each of these square roots, we can apply this, have a product underneath them, which means we can apply the square root to each factor individually. So we've got root 4 times root 5 plus root 9 times root 5 plus root 16 times root 5, which means we're going to have 2 root 5 because the square root of 4 is 2, plus 3 root 5 because the square root of 9 is 3, and 4 root 5 because the square root of 16 is 4. So we have 2 root 5 plus 3 root 5 plus 4 root 5. So 2 plus 3 is 5, plus 4 is 9, so we just end up with 9 root 5 in the end. And that is that.